The Sure Test Model 61.157 can cause ground fault circuit interrupters, GFCIs, to trip when plugged in due to its method of determining ground impedance. When the device is plugged in, it automatically places a 15-amp load between the line and neutral, LN, and another load between the line and ground, LG. This is part of its normal operation for ground impedance testing, but can inadvertently activate the GFCI. When a GFCI trips, the immediate solution is to reset it. The GFCI has a reset button. Pressing this button restores power to the circuit, allowing testing to proceed. However, if the tripping persists, consider an alternative approach using an isolation transformer. An isolation transformer provides a barrier between the device and the GFCI protected circuit, preventing the test load from directly affecting the GFCI. The steps for using an isolation transformer are: firstly, connect the isolation transformer to the outlet that is protected by the GFCI. Secondly, connect the Sure Test Model 61.157 to the output of the isolation transformer. Thirdly, after making these connections, reset the GFCI. Fourthly, you can now perform the ground impedance test without causing the GFCI to trip. Safety is paramount when working with electrical equipment. Always adhere to the safety instructions supplied with the Sure Test Model 61.157. Ensure that the isolation transformer is adequately rated for the intended load to prevent overloading and potential hazards. Never attempt to test live circuits without the necessary training, qualifications, and appropriate personal protective equipment. Before using any electrical testing equipment, visually inspect it for any signs of damage, such as frayed cords, cracks in the housing, or loose connections. If any damage is found, do not use the equipment and have it repaired or replaced. Use appropriate personal protective equipment, PPE, including safety glasses, insulated gloves, and appropriate clothing. Avoid wearing loose jewelry or clothing that could get caught in the equipment. Always work in a dry environment. Avoid working in damp or wet conditions, as this increases the risk of electric shock. When using an isolation transformer, ensure it is properly grounded. This provides an additional layer of safety in case of a fault. Never bypass or disable safety features on any electrical equipment. These features are designed to protect you from electric shock and other hazards. Be aware of your surroundings. Ensure that there are no flammable materials or other hazards in the work area. If you are unsure about any aspect of electrical testing, consult with a qualified electrician or electrical engineer. Only qualified personnel should perform electrical testing. If you are not qualified, do not attempt to perform electrical testing. Always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized before working on it. Never assume that a circuit is de-energized even if the power switch is turned off. When working on electrical equipment, use insulated tools. This will help to protect you from electric shock. Keep your work area clean and organized. This will help to prevent accidents. When finished working on electrical equipment, be sure to clean up your work area and dispose of any waste materials properly. Be aware of the potential hazards of electricity. Electricity can be dangerous if not handled properly. Always take precautions to protect yourself from electric shock and other hazards. Ground impedance testing is a critical part of ensuring electrical safety. It verifies that the grounding system is functioning correctly, providing a low impedance path for fault currents to flow back to the source. This low impedance path helps to trip circuit breakers or fuses quickly, preventing electrical shock and fire hazards. High ground impedance can result in slower fault current clearing times, increasing the risk of electrical shock and equipment damage. The Sure Test Model 61.157 is designed to measure ground impedance accurately, but its test method can sometimes interfere with GFCI protected circuits. Understanding how to mitigate this interference, either by resetting the GFCI or using an isolation transformer, is essential for effective and safe electrical testing. When interpreting ground impedance test results, consult relevant electrical codes and standards to ensure compliance. These standards provide guidelines for acceptable ground impedance values and help ensure the safety of electrical systems. Regular ground impedance testing should be part of a comprehensive electrical maintenance program. This helps to identify and correct potential problems before they become serious hazards. Furthermore, ensure that all electrical connections are properly tightened and free of corrosion. Loose or corroded connections can increase ground impedance and reduce the effectiveness of the grounding system. Regularly inspect grounding conductors for damage or corrosion. Replace any damaged or corroded conductors immediately. Grounding electrodes should be installed in accordance with electrical codes and standards. Ensure that the electrodes are properly sized and installed to provide an effective grounding path. Periodically test the resistance of the grounding electrodes to ensure that they are still providing an adequate grounding path. If the resistance is too high, take corrective action, such as adding additional grounding electrodes. Electrical codes and standards, such as the National Electrical Code (NEC), provide detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety of people and property. Stay up to date on the latest electrical codes and standards. This will help you to ensure that your electrical systems are safe and compliant. Proper grounding and bonding are essential for electrical safety. By following the guidelines outlined in this discussion, you can help to ensure that your electrical systems are safe and reliable.